Hi, my name is Chris Barret. I'm a professor at Cornell University in the United States, and it's a great pleasure to get to speak with you today. So I'd like to talk with you about the origins of IBLI. Why did we design this product? And then what have we come to learn about IBLI and its effectiveness, its impacts? First, it's important to understand the context. IBLI was designed for a very specific context. A number of us had been working on studying risk management among pastoralists in northern Kenya and southern Ethiopia for some years, since the mid-1990s. And one of our central findings from that research was that there really existed poverty traps, that there were self-reinforcing equilibria in which people became poor and were just stuck in poverty because of underlying drought conditions.
So the graphic you see on the lower left is a really simple bivariate non-parametric regression. You just have on the vertical axis herd sizes in the future, and on the horizontal axis herd sizes today, both in log terms in this case. And so you see simply here the non-parametric regression at 1 year and 10-year intervals for those, what we often refer to as a recursion diagram, because it's just a recursive relationship between the future and the present. Now, notice how one interprets this. You've probably seen somewhat similar graphics in macro classes when you're trying to map out path dynamics. Notice that in the left third of that diagram, what we label as the sedentarization zone, that recursion diagram is beneath the 45-degree line. The 45-degree line is where tomorrow and today have the exact same value, i.e. that's a dynamic equilibrium. But to the leftmost portion of this graphic, you notice that recursion diagram crosses that line once and crosses, as you move from left to right, crosses from above. So if you just think about what that means whether you're on the left or the right of that equilibrium, the path dynamics carry you back to that point. And 0 as the log of something means that low-level equilibrium is 1 cow. This is expressed in tropical livestock units, which are equivalent to a cattle unit. So we could very clearly and fairly precisely identify a low-level equilibrium of 1 cow, which is exactly what happens when people lose their herds and they can't migrate, so they keep 1 milk cow around the house, which can be grazed locally without the stocking rate getting so high that it overgrazes the rangelands. The picture you see on the right is a fairly typical view of fairly degraded rangelands where there's just not much grass available, and so you find dead cattle carcasses. Notice as you move into the recovery zone, now the recursion diagram crosses that 45-degree line from below as you move from left to right, which means that's an unstable equilibrium. There's a tipping point. So that tipping point, which depending upon which data set we use, seems to fall somewhere in the 6 to 15 head of cattle range, or cattle equivalent range, in this and several other data sets we've now generated from this region. That tipping point is the tipping point where people can now become mobile. And here it's important to understand the system. Just above that tipping point, a drought comes and kills off a third of their herd, and they collapse back to that 1 cow low-level equilibrium. Then managing that drought risk so that when bad things happen, they don't have to wait for the biological reproduction of the herd to enable them to grow their herd again. They could reconstitute their herds faster through indemnity payments from an insurer. That was the essence of trying to break the poverty trap.
So the big driver of the poverty trap conditions in the pastoralist regions of this part of the world come from catastrophic herd loss during drought. That is the single biggest reason for the existence of the poverty trap. And this puts a big emphasis, a big policy premium on finding ways to manage drought risk effectively, both for individuals and for society at large. The references, by the way, on all of these slides will direct you to the relevant research if you're interested. Now, the presence of stochastic poverty trap, a poverty trap based off of risk exposure and the realizations of catastrophic events, this gives rise to something that my co-authors and I refer to as the paradox of social protection. And that is the paradox that we try to prioritize social protection for the poorest in society, but if we fail to provide insurance against catastrophic loss to those who are, if you will, the middle class of society, as those with migratory herds commonly are in these regions of the arid and semi-arid lands, if we fail to provide insurance against catastrophic loss, then those folks cease to be viably non-poor. They cease to be able to take care of their own families using their own skills by migrating herds in search of forage and water according to how the seasons and the rains move. So in that case, if we fail to insure those who do own viable herds, they simply join the ranks of the very poor and add to the stock of indigent persons who quickly overwhelm social protection systems. So the paradox of social protection is sometimes in order to serve the needs of society's poorest over an extended period of time, we have to ensure to allocate resources not just to the poorest, but also to provide credible insurance to those in the middle class. Now, that situation is only becoming more acute and more urgent in the context of climate change. Pastoralism is a highly adapted system. It is built precisely to address the fact that the rains come in different times in different places, and you can move animals there when you can't move crops. But our systems haven't adapted to the rapidity of climate change that we've been witnessing over the last generation or so. And one thing we've been able to establish through simulation modeling based off of taking detailed data on herders' understandings of their own herds' state conditional year ahead growth, mixing that with rainfall realizations, we can simulate what happens when we start to see more frequent drought, when we start to see rainfall in particular below 250 millimeters a year in these areas of southern Ethiopia where we study this. And what we find is in those contexts of more frequent drought, the likelihood of complete system collapse increases, that the recovery time for herds hit by drought becomes so short that herds simply can't recover. And over time, almost all households' herd sizes shrink down to a low-level equilibrium of a single cow, which translates into indigent communities and lots of social problems. So a combination of the social protection paradox that puts a premium on providing insurance and the prospect that without doing something to help accelerate herders' recovery from droughts as droughts grow more frequent and more intense, then we're going to see system collapse. So the need for insurance becomes all the more acute. Now, the usual responses that have existed in this region, first is post-drought restocking, simply providing another cow to households who have lost much of their herd. Without going into the details, that's ultimately a fairly futile exercise precisely because of the poverty trap mechanism. Households that have relatively small numbers of animals simply can't regrow their herds fast enough before the next drought hits and knocks them back down. So that's a fairly futile exercise if you're only providing 1 or 2 cows at a time to households. Food aid is the other main response, and that's a very slow and expensive mechanism. It can also inadvertently reinforce sedentarization, which simply reduces the viability of transhuman pastoralism. And this leads to demonstrably high rates of excess human as well as animal mortality. Moreover, these common responses, drought restocking and food aid, can lead to a vicious cycle in which people become excessively dependent upon the natural resource base. They begin to take what limited woody species are available, turn them into charcoal, further denuding the land and winding up reinforcing the very problems that have given rise to herd loss. So we need different responses. Insurance was a natural response to thinking about catastrophic risk exposure that's causing poverty traps, and that could become an even more important cause of systemic collapse in years ahead with climate change. Because insurance can most obviously stop that downward slide. It reimburses people for catastrophic loss. But moreover, by being insured, it can crowd in investment because people see increased risk-adjusted returns to the investments they make. And so if part of what holds back poor populations is insufficient investment incentives, then insurance can also help crowd in investment, both from the supply and demand side. It can also crowd in bank lending. So financial deepening is another potential impact of providing insurance as correlated default risk gets reduced, and so financial institutions become more likely to be willing to lend. And it enables the focus of humanitarian resources on the most needy precisely by addressing that social protection paradox. By providing insurance so that the middle class can get back on its feet quickly, you can concentrate directed social protection resources on those who most need humanitarian assistance. The problem, of course, is that conventional indemnity insurance, like many of us have on our homes or our automobiles, is just unavailable for livestock in this setting, primarily because of very high transactions costs. These are rather sparsely populated areas, and the cost of going and selling product and doing claims adjustment and providing indemnity payments is excessively high. But also because of, in particular, the moral hazard problem. It's hard to know why someone's cow died, and this creates a lot of perverse incentives. So we decided to try index insurance, an instrument that was still relatively new when we were first working on this in the late 2000s. We first piloted IBLI in northern Kenya in January of 2010. But also this was seen as a mechanism that is relatively low transactions costs, especially by eliminating the need for claims adjustment. And it also essentially eliminates moral hazard problems. So we thought this was worth a try. Without getting into the details of product design, the basic idea behind the IBLI product was there are two rainy seasons typically in this area of northern Kenya and southern Ethiopia, and we'd set up two sales periods during the dry seasons, just before commonly you would start to see the long rains come, starting sometime in March, and the short rains come starting sometime in October. So you'd have two-month sales periods during which people could buy a 12-month contract that offered the possibility of payouts at either of the ends of the two usual long rain, long dry combination periods. And the idea was that the first 15% of loss would be absorbed by the policyholder, and everything thereafter would be paid back through an indemnity. But the indemnity was tied to the predicted value of livestock loss in that area, where the predicted values were based off of a statistical function we built off of historical livestock mortality data, calibrated to satellite-based measures of normalized difference vegetation index. So we could use the freely available near real-time availability of Earth observation data now to build a reasonably accurate predictor of herd mortality through this region and turn it into a put option that could underpin an index insurance contract.
This is an index that is built off of objectively verifiable data. It's remotely sensed data, publicly available. Anybody can access it. No part of the contract can manipulate what NOAA is going to publish. It's very low cost. It's available in near real time. This is what you want for an index insurance design.
So that design went into place in 2010. The design has been adapted a few times in response to feedback from insurers and reinsurers, as well as the communities who we've been serving. But we started this with an original design across parts of northern Kenya, what was then Marsabit District, now parts of Marsabit County and Moyale County. And then about 2 years later, we launched an analog product, slightly different design, different set of commercial partners in southern Ethiopia in the Barret region. And we intentionally built into those launches a research design where we overlaid in Kenya the Hunger Safety Nets program, the cash transfer program the government of Kenya was launching at the same time. We overlaid the HSNP coverage with areas in which we would randomize discount coupons for purchase of IBLI. We likewise randomized discount coupons for purchase of IBLI in areas of Barret and southern Ethiopia. And we could use that design to both compare IBLI against HSNP in the Kenyan case, and in both cases to be able to come up with a credible experimental design so that we could identify the causal effects of IBLI on the ultimate impacts on the target pastoral, agro-pastoral populations. So we found that in our survey populations, not in the open population that we didn't survey, but those who we were surveying and among whom we were providing these these premium discounts as well as some marketing to assist the insurers, we found uptake was quite robust, much higher, I would add, than one commonly finds for index insurance products for crop cultivators. If you look at maize index insurance uptake, for example, the rates are typically much lower than this. Within the first 4 sales periods in both countries, we saw roughly half of households purchased IBLI at least once, but the repurchase rates were relatively low. We had a minority of people who tried it once continue to purchase routinely thereafter. That raises a variety of questions around understanding, around trust in insurers, around the liquidity of households. So those continue to be vibrant topics for research to really pin down precisely what is it that keeps people from coming back to purchase IBLI routinely in the years ahead. A lot of this seems to have to do with the price. I'll come back to that later on. But there were relatively high rates of disadoption, which to us was also a clue that while this seemed a good product, it clearly wasn't a perfect product. There were going to be shortcomings in it. Now, there were shortcomings. I'll come to those in just a moment. But the key takeaway message, the real headline result around IBLI was it generated a lot of positive impacts across lots of different dimensions. Rigorously designed, peer-reviewed research found that it was increasing households' veterinary expenditures, and the milk income per cow was increased, or per tropical livestock unit was increasing. Household income was increasing. Children's nutritional status, as represented by bit upper arm circumference, increased. We saw in particular improvements in drought years. So households that purchased IBLI versus households that didn't purchase IBLI, taking care of the causal side through our design, those households were doing better and they felt better. Their subjective well-being was much higher than those of households that didn't purchase IBLI, even though after a contract period had lapsed, they regretted having spent money on a product that never paid off, but they still found it more worthwhile to buy the product, even if they could reasonably anticipate prospective buyer's remorse. We found in particular reduced distress sales during periods of drought. And we saw reduced meal skipping by poor households in response to drought and the indemnity payments that came to IBLI policyholders. And this was crowding in informal transfers within communities. So this was helping to reinforce the existing social solidarity networks rather than competing with them. And this was all together generating relatively high impacts. Indeed, impacts that at the margin, as compared to the cash transfer program at the same time in the same place in northern Kenya, the marginal impact of $1 spent on IBLI versus $1 spent on HSNP was 6 to 45 times higher, depending upon what outcome variable you like, but consistently higher and by a very large margin. So this was clear evidence that there are positive impacts, and relative to the cash transfer programs that have been so popular, IBLI seemed a very cost-effective way to address the very real problems created by drought and poverty in this region. Now, it was incomplete and imperfect risk transfer. Covariate risk is very important in this area. Covariate risk, most importantly, in the form of drought, but household losses vary a lot within a given location that experiences drought. If places don't experience drought, there's relatively low average losses, but there are still some households that lose a lot due to disease or predators, sometimes just poor husbandry. But even for a given household over time, so even for a household that practices good husbandry, there's a fair amount of risk variation over time relative to their fellow residents. So the bottom line was that IBLI has a really positive impact, even though it's only picking up 1/4 to 1/3 of the risk. Most households were still holding somewhere between 62 and 77% of the total livestock mortality risk exposure. So IBLI was a highly impactful product, but incomplete and imperfect. So the key here too is that the imperfections in IBLI seem to be largely around idiosyncratic risk and not targetable. So this was largely just random variation across households and across locations that makes it very difficult to substantially advance the product design to squeeze out the remaining risk transfer potential here. So the takeaway here is IBLI is a positive, impactful product, but it's not a standalone intervention. It needs to be coupled with other things. Now, that successful track record led to quite rapid scale up across the original domain of southern Ethiopia and northern Kenya, where we originally launched the product in early 2010, as you can see in the blue in the 2010 panel at the top. And then if you just read left to right and top to bottom, you can see through the coloration here with a scale at the bottom, how the IBLI coverage in any given season has evolved. And you see that it's scaled up dramatically, in particular in Kenya, thanks to the Kenya Livestock Insurance Program, CLIP. So ultimately, the takeaway here is IBLI is an incomplete and imperfect risk transfer product. It is not a magic bullet, but it provides very effective evidence. It provides very effective coverage against catastrophic herd loss. Uptake has been strong. There are clear positive impacts on producers. It just needs to be coupled with other things. This is a very promising option for addressing the poverty traps that are very real in this part of the world and that can arise and become aggravated with climate change and the catastrophic drought risk increases that come along.